Alrighty, so now for actually doing the proof portion. For the first part of the proof, I want you to try to get ahead of me. So if you all should be able to do everything up until this last. So if you want to pause the video and try to do the proof through this given and these two givens, do that now. If you want to pause as we're going along, you can do that as well. And I highly because there is a difference between doing a proof with me and doing a proof on your own. Alrighty, so and as always here, I'm going to be pausing the video perhaps a little bit more because we should be good as far as proving this first part. So I'm going to pause the video and make the first given. Okay, first given here, AB is congruent to EF. So I wrote it up here with my given number 1. I drew it down here, and then that we can really get, we don't parallel lines, we don't get isosceles triangles, freebie. Okay, it's just a freebie, so I'm going to check off that given and move on to the next two. Another little side note on these perpendicular pieces, if you've got two perpendicular statements right next to each other, you can really just treat them as one single given. So pause the video, see if you can find the along with this one, and the conclusion, see if you get it right. I'm going to pause and write that all out now. Alrighty, so here's my given that both of those are perpendicular to each other. We have two sets of perpendicular lines. We're going to be trying to get two sets of congruent right angles, or just two congruent right angles. So our theorem is perpendicular lines create congruent right angles. Our conclusion here is that we have a right angle here, and all right angles are congruent. Sweet. Now we're on to this new given that I just talked about in the previous video. So I'm going to draw these lines again, and let's see. On your sheet while I'm doing this, you should be looking for the theorem that talks about segments being too long. So you got AD here, and let's go with it deeper blue. Save. Alrighty. Okay, so if we're looking on our theorem sheet, given segments too long, okay? In this, you can see that we've got AE and let's see, DC, and their overlap is right here. We use the reflexive property to subtract that segment that they both have in common, because if you remember, a segment is congruent to itself. So if this whole green segment is 5, this whole purple segment is 5, and where they both overlap is 2, then this little leftover piece will be 3, this little leftover piece will be 3. So our theorem and our given we can put in our proof. Where's my pause button? Here. Alrighty, so I've put everything here for the step 3. We start out with our given, as always. We copy down the theorem that congruent segments that are too long to be triangle sides, those require segment subtraction. So we copy down our given, we subtract the thing that they have in common using the reflexive property. The reason the letters are switched, if for AD we follow the order in this direction, it's ACD, ACD, and then over here it's EDC if we go in this direction. So you want to try to keep that correspondence accurate. And that leaves us with AC, which is this side of the triangle, congruent to ED, that side of the triangle. I remarked all these congruent parts, sides and angles, in green. And now we have 3 pieces that are congruent. So how about you take a look here and think about what type of triangle congruence we have. Try to find the theorem. Hint, it's on the last page. And so if you're looking at this correctly, we've got side angle side. I drew an S, an A, and an S. So I copied down the theorem and said that my 2 triangles are congruent. I made sure that my order of my letters was correct. I started with the right angle, then went up, and then back down to the line. Same thing over here, start at the right angle, went down, and then over to here. Alrighty, we're not done yet. We still had to prove this last piece congruent. So our step 5, should copy down the theorem, find it in the sheet, see if you get the same as me. And there you have it. Congruent triangles have congruent corresponding sides and angles. So our conclusion is that BC, which is the hypotenuse here, is congruent to FD, which is the hypotenuse here. All right, so that's segment addition and subtraction, or just segment subtraction. Segment addition is really the same thing, except instead of subtracting the piece that they have in common, you're adding it. So you don't have enough. I'll give you an image of what that looks like. So here we're given that AR is congruent to TC. We need to add this middle piece to both of them. So, and the theorem is right here. It's pretty much the same thing. So try your hand at that and see how you do. Okay? Next video is going to be on linear pairs.